Hey everyone. So we're going to talk about one of the most powerful and useful blocks in Python, which is loops. We usually want to loop over a lot of items, and particularly in something like Houdini, where you've got geometry, you've got a whole bunch of points, a whole bunch of attributes. You usually need to do a lot of looping to achieve the results you want. So very, very powerful. Okay, so there's two main types of loops in Python. I mean, there are other sort of subtypes, but really there's the two main ones, which are for loops and while loops. So let's start with the for loops because they are the sort of the easiest to understand and probably the more commonly used ones. So again, I'm going to create a list. So I'll call it my list, and we'll just make a let's just say A, B, and C. Okay. So we'll use some strings now instead of numbers. Okay, so we've got a list, and now what we can do is essentially loop through this list and do something again and again, so a block of code repeatedly for every item in this list. That's why it's called a for loop, because for every item in this list, we want to do a thing, a block of code, right? So we say for, and then we need to choose a variable. So we're going to feed it my list, but the thing is, when it's looping through my list, and on the first loop, the first iteration, the item in question is A, right? The string of the character A. It needs to store that in a variable. I can't just use my list because my list is a variable that stores the full list. I need a variable to store the one item in the list. So this could be whatever you want. It could be X. So for X in my list means that it is going to, on the first iteration, X is going to be A. Then on the second iteration, X is going to be B, and then it's going to be C. All right. So, but this could be anything. So it could be X, it could be A, it could be my item. So it can be not just a single letter, but it can be a longer description, whatever it is. Right? Other than reserved keywords, you can basically make it anything, just the same way that a variable can be anything. This is literally just a variable. It's just a temporary variable that only lives while this loop is running, and then afterwards that variable is cleaned up and not used again. I say cleaned up. I do actually think it still exists and it holds the last value that it had. Don't quote me on that, but I think it does. So we can check just now, but I think it does hold the last value, so you could actually still hold on to and print X, and it would be equal to C because it would loop through everything and the last value would be C. Anyway, so again, we put colon at the end and we tab in, and then we can do something. So, usually just for visibility, the easiest thing to do is just print, but whatever you want to do as well. Right. So you'll see there, when I click apply, it prints A, then it prints B, then it prints C, because it is looping. And so that print is doing it on separate lines because it's literally running multiple times. So it's as though I have typed print my list 0, and then print my list 1, and then print my list 2, right? But obviously you don't want to have to write that line of code again and again. You just print this and you loop through the list and you give it a variable. And let's actually test what I was saying if we print X afterwards. So you'll see, well, let's do it again. It prints A, prints B, it prints C, and then it prints C again. So that print over there is this one, but you'll see that it runs all three of these first. So it literally loops, like it stops here, it loops 3 times, then it continues. So this line will only happen after these are done. All right. Okay, so that's just a basic for loop. Now, I do want to talk about another sort of a very useful function, very, very useful, called enumerate. But I first want to just explain that while we're looping through, and we feed it a single variable, because when it loops through a list, each index is just one variable. Like it's just one value, so it needs one variable to store it. If we feed it anything that has 2 variables, right? So it's a list of tuples, then we would need to feed it a variable for every item in that tuple. Okay. Otherwise, with one variable, it's going to store the whole tuple as the one variable. And it's important to understand that, because when we do this enumerate, so I'm going to, I'll show you what this does now. We wrap our list that we're going to loop through in an enumerate function. And what that's going to do is build an iterator that has essentially an index number and then the value, and it's going like almost as a pair. So it's kind of almost like building a dictionary, except that instead of it having a key and a value, it's the index number and a value, right? Because did you see here we were printing x, but x was just ABC. How do we know that we're on the 5th iteration, or the 10th iteration? Maybe we want to stop at a certain point, so we want to keep track of the number, not just the value. Because our numbers, even if we had numbers here 1, 2, 3, 4, 5, can't be guaranteed that when we get to number 10 that is the 10th iteration, because these lists could be in any order. So if we want to basically have access to an index number while we're looping, we have to enumerate our list. So we wrap it in an enumerate function, and then it's going to expect 2 variables, one for the index number and one for the value. And the index number comes first, so it's I, x, right? Or you'll usually see this as I, v, but you can just make it any variable you want. Even the I could be something else. You could call it index, or you could call it, whatever you wanted, but usually I will just use I. So I, x in enumerate. So this is the way you would write it. And what it means is that it's going to go through. Now, if we print again, it's going to do exactly what it did before, because we're just printing x. It doesn't change x. X still just lives there, and it is the value of every item in that list. But what it gives us access to in this block is now another variable called I. And so if I printed, let's just add another print. So we'll just say print I and then print x. And what that's going to look like is this. So on the first iteration, it prints I, which is equal to 0, and then it prints x, which is equal to a. Then it prints I, which is equal to 1, and x, which is equal to b, and then 2 and c. So it gives us that index number, which can obviously be very useful, because you might then want to build some other block saying if I is greater than 0, then print x, right, or whatever. So maybe on the first time we don't want to actually print it. So now it's just going to print 0, then 1, b, 2, c. So in fact, if we get rid of that, so we comment that out, you'll see it's basically going to just print b and c. So even though it does loop 3 times, when it hits a, because I was 0 on the first time, I is not greater than 0, therefore it will not do the print, and it'll only do the print when I is bigger than a certain number. Okay, so however you want to structure that, you can use that I now as an index number. And so if you want to know what number you're on versus which item we're actually looking at. Okay, now what if we wanted to loop through a dictionary? So let's actually create, I'll leave my list there, but I'll create a dictionary, and we'll just call this, we'll use the usual example. So I'll make someone, that's 35 and their name is Steve. I keep picking on Steves here. Sorry if there's someone out there called Steve. I promise I'm not picking on you. It's just the first name that comes to mind. Okay, so age, name, and height, right? But we want to loop through this dictionary instead. So let's get rid of that. So we do for, and we can do for my, we would need to give it a value. So for x in my dictionary, so my dict, then print x. Okay, and let's see what this does. Now it doesn't fail, but it just, x essentially as we're looping through just gets the keys, okay? And it's not really good practice to do that. If we really specifically wanted the keys, we should actually use the .keys function. So remember I showed you that the .keys, the .values, and the .items. So even if we deliberately wanted that, it would be better to say .keys, okay? You can also do .values, and then that's going to give us 35, Steve, and 1.8. But if you want access to both, then you use .items, but you also then need to give it two variables to store those two values in. All right. So obviously, if we don't, because they're a tuple, x is going to then become a tuple, and maybe that's okay. Maybe you are happy to just have it be x, and then inside of here you keep wanting to use an index number to fetch either the key or the value. But it's better to actually give it a key and a value variable instead. It's just much easier and usually better practice. And we'll often use k comma v because it's key and value, right? But again, you can call it whatever you want. So in this case now, k and v, so k becomes equal to the key, v becomes equal to the value, and then we can do whatever we want. So we can print k and then print v. And we hit apply, so you'll see it prints age 35, name Steve, height 1.8. So now within this loop, we have access to two different variables, the key and the value. A lot nicer than having it stored as a tuple and having to constantly split it up. Okay, so that's how we would loop through a dictionary. As I said as well, if you only want to loop through the keys or something like that, then you can, but then you just say use the .keys expression. Okay. I actually just want to test something. If we just feed it the dictionary and two variables, no, see, okay, yeah. So we have to feed it. If we just loop through the dictionary, it just essentially defaults to giving it just the keys, which is not great. Okay, so .items is going to be your friend when it comes to looping through dictionaries. Okay. Now, let's move on to while loops. So with a while loop, it's essentially going to loop until a certain condition becomes false, right? So as long as, or in other words, while a condition is true, it'll just keep looping. And then it waits for the condition to go false. It's almost like having a switch on. While the light switch is on, the light keeps producing power. It doesn't just flash once and then go off. It stays on until the switch is false. The switch is off, and then it stops looping. So that is a while loop. So we can create a variable here called condition, just so we can have something. And then let's say, or it could be, maybe like a count or something. So we'd say maybe count equals 0. And then what we do is we say while count is less than, let's start a small number. So while count is less than 5, it's going to keep looping. So obviously count is 0, so it's going to execute the block of code. And then it's going to keep executing the block of code, unless, of course, we change the count value inside of that block of code. So you need to be very careful at this stage, because you could easily create an infinite loop. If you do not alter count over here, you will end up with an infinite loop. So we say count plus equals 1. So inside the loop, the very first thing you would do is make sure you increment that count. And then you could do whatever. So now we could say maybe print, hello, right? So, and I hit apply, and it's going to print hello 5 times. So this is an easy way of saying I want to execute this block of code exactly 5 times. Or, of course, this could also be a variable. So how many maximum times you want to loop can also be some kind of variable. So that could be based on like the number of items in here or whatever, okay? You could let the user choose a number of them or anything that you want. And then as long as you're adding to this value, because then on the first iteration, count is going to go from 0 and it's going to go to 1. Then it's going to exit the loop, enter the loop again. Count is now equal to 1. 1 is less than 5, so it says, yes, this is true. I'm going to do the block of code. Count now becomes 2, prints hello, goes back to the beginning. Is 2 less than 5? Yes. Do the block of code again. And it keeps going until 5 is less than 5. No, 5 is not less than 5. False. So then it doesn't do anything more. It exits the block. Now, when working with while loops, there is another very common way of kind of working with them rather than relying on the condition to decide when it should exit the loop, which is to deliberately make an infinite loop. But then within the loop, we actually break out of the loop. So I'm going to show you these stop conditions that can be used to break out of loops. And, since we're on the topic of while loops, talking about break is quite commonly used. So in this case, we would still want to count. So 0 and you can +1. It's not always count, by the way, but I do recommend when you have an infinite loop, having a count and having a backup that you sort of maybe break out after 1,000,000 times or something, just so that you don't do it too much. It prevents it from going infinite. Now, if we just say while true, right, or while 1, then it's just always going to be true. It's not tied to the count anymore. So the count will still increment, but nothing will cause it to stop. However, what we can do is enter a statement over here, an if statement, saying that if the count is now greater than 5, then we break. Okay, now break just means once it hits this line and executes this, it will skip all of the code within the rest of the block and will not enter the block again. And the block it's referring to is not its own if block, but the nearest loop block that it is in. So if you're in nested blocks, so nested while loops or nested for loops or whatever, it's only going to break out of one loop. So it will not, you'll need to do 2 breaks to get out of the whole, the parent loop if you're, inside of a loop inside of a loop. So it breaks out of just 1. But in this case, there is only 1, so it's going to break out and execute whatever this line is. So the very next line that is outside of that loop. Okay, so you can kind of see something that's on the same indent level as the loop. So we'll say print finished looping. Something like that, okay. So now when we print, it's going to print hello 5 times and then say finished looping, because count reached a point where count was 6, so count was greater than 5, and then it broke out without printing hello. So even though count will be 6, it only prints 5 hellos because the last time it incremented the count but did not do the print. Okay, so that's a way of breaking out of loops. Not only while loops, you can also use break inside of a for loop. Another way of getting out of a loop is using a continue function. So I'm going to show you how that works, and the easiest way to show that is with the dictionary. So I'm going to do a for loop with my dictionary. I'm going to say for k, v in my dictionary dot items. Okay, and then let's say we want to print k. But then if let's actually add a count in here as well. Okay, so we'll say count equals 0. Every time we enter the loop, we plus equals 1. But then what we're going to say basically is after printing k, if count is greater than or equal to so let's do 1, right? So because count will on the first time it's going to be equal to 1, because remember it starts at 0, but on the very first time it increments anyway. So if it's greater than or equal to 2, then we're going to continue. All right. And then after this, I'm going to print v. And then let's see what happens, and I'll explain why. So make sure that we can see. So it prints age, it prints 35, then it prints name and height. So we never printed Steve and we never printed 1.8. And why is that? So on the first time, count was 0, then it enters the loop and makes it plus equals 1. So count is now equal to 1. It prints k, which is age, and then it says, is the count greater than or equal to 2? Where at the moment it's 1, so no, this is false, so it does not continue. So then it moves to this line. Then after this line, the block is done, so it starts the loop again. On the next loop, however, so k is now equal to name and v is equal to Steve. Count gets incremented again, so it used to be 1, now it's 2. It prints k, which is name, so you see there, it printed name. And then count, if it's greater than or equal to 2, well, this is true now, because count is 2, which is equal to 2. So therefore, it's going to run this line of code. And what continue does is basically says, do not finish the block of code, but do return to the beginning and re-enter the next iteration. So the fact that there is a height value over here means there is one incomplete iteration. If we put a break here, we would not get height at all. We'd get age, 35, name, and then it would not print Steve because we've broken out before it could do that print. But we also don't get height and 1.8 either because it will, after the break, will not even re-enter the loop. Whereas continue will skip the print of V, but it will go to the next iteration. The next iteration is height and 1.8. So K is height, V is 1.8. It increments, so now count is equal to 3. It prints K, which is the word height. So you see it did print height. And then again, it says, is the count greater than or equal to 2? Well, 3 is greater than 2, so yes, true. So it will continue and therefore skip this line. Okay, so continue is essentially saying go to the next loop, well, go to the next iteration. Break is saying don't go to the next iteration, but both of them skip the remainder of the block of code and instead go to either some point, either the beginning of the loop or outside of the loop. Okay. Now there is one other one that can be mentioned, which is return, but return is kind of like breaking out of not a loop, but breaking out of a function. So because we are not building custom functions yet, I don't really want to go into that, but just know that there is another one called return. So if you see return, you'll know what that is. It's similar to these. It's basically similar to a break. Except what it does is it breaks out of the function and returns some kind of value, or you can even return no value. But it exits not a loop, it exits a function, right? So you can build your own custom function, and then when something happens, you can tell it to say, right, stop running the function and just exit the function, and either give the user a value or don't give them a value at all, just give them a none. Okay, so that's a very brief explanation of what return does, but because we'll return to that, ironically, when we do custom functions and things like that. Okay, so you will see return quite commonly, but I don't want to handle it now in the wrong lesson. Okay, so that is basically loops, and you will find them extremely useful, very powerful, commonly used. So if this lesson was a bit confusing, or that's a lot of information, please just watch it a couple of times. There's also loads of resources online to learn more about loops in Python, because this is going to be your bread and butter, so you must make sure you understand this. Although if you just mildly understand it, I promise it'll make more sense when we actually use it on tools, because you can see it in practice rather than just these hypothetical examples. Okay, so I'll see you guys there.